Lab 1, constant velocity. So the purpose of this lab is to observe the motion of an object moving at a constant speed without changing direction. The tracker will show the actual position of the object, while the GlowScript code will show the predicted position. This lab will help students better understand Newton's second law. So the physics principles I'm going to use in this lab are Newton's first law, which states that an object in motion or at rest will remain in its current state unless acted upon by an outside force. Newton's second law, which states that the acceleration of an object is determined by the mass of the object and the net force acting upon the object. And then the formulas I'm going to use are down here. So the velocity formula, which is, change in position over change in time, and the change in velocity formula, and then the change in position formula, which is right here, and then the velocity update formula, which is right here. So the procedure and conditions. A wiffle ball is rolled at an initial velocity from an initial position of x equals negative 1.955. The net force of the system is assumed to be 0, and the surroundings include everything in the room, including the floor, the air, everything in there. So Tracker, which is what I'm using for this lab, is a software that tracks the position of the ball in my video at equal time intervals. The results for my video are shown below. Right, here's the tracker analysis. So the ball rolled for a total of 2.033 seconds from start to finish. The ball started at position negative 1.95500. So from t equals 0 seconds to t equals 0.033 seconds, the ball went from this position vector here to this position vector, meaning the ball had an initial velocity of negative 711.06 meters per second, which obviously is not true, but we're going to use it for the purposes of the lab. And then here is the formula I used to get that initial velocity. So here's my GlowScript code. So net force is set equal to 0, and delta t is set equal to 1 over 30 because the video is at 30 frames per second. So here's my initial net force vector, here's my initial position vector, and my initial velocity vector. I explained how I got these numbers in the previous slides. Here is my ball mass value. The mass doesn't actually matter because the net force is assumed to be 0, but that's the mass. And then here's the formula I used to find the velocity, or to update the object's velocity. And here's the form I used to update the ball's position. So here I'm going to compare the results. So the red line is the GlowScript, predicted position, and the blue line is the tracker. So we can see it's a little inconsistent here at the start, but then as it goes on, the red line kind of starts to overestimate the position of the ball, and the blue line, while having some inconsistencies, is that's the actual position. It's less than the red line. So we can attribute this to a few things. Obviously, there can be some errors in the tracking. There likely were, caused by me, misplacing the center of mass ever so slightly. But the more, kind of physics answer would be that there are some outside forces acting on the ball, like, for example, air resistance or friction, that are affecting its motion and affecting its position. So here are some additional questions. What if the positive x and negative x were interchanged? The only thing that would really change would be the slope of the graph, which would change from negative to positive. And what does it mean? Since the GlowScript code incorrectly estimates the position of the ball, that means that the net force on the ball is not 0. So since the net force is not 0, that means that there must be other forces acting on the ball. Thank you for watching.